And we should be live now. Good morning, everybody. Well, morning for me. Hello, Kagglers. I'm going to try to start saying that instead of good morning because it's not morning for everybody. And for many people, it's actually quite late at night. All right. Today we're going to be working on live coding, and the specific project that we're working on is going to be a continuation of the project that we've been working on for quite a while now. And it is a summarization. Oop, that sounds good. Get rid of the echo. It is a project to quickly summarize what's going on in the Kaggle forums, basically. And this is going to be, well, not completely in lieu of, but to augment, I guess, the work that I do, which is I just read the forum posts every day, and it takes a really long time. I don't know, if you've been on Kaggle for a while, you may not be surprised to hear that, but we get a couple hundred forum posts per day. I don't actively monitor the competition forums, but the competition forums are also another source of a couple hundred forum posts per day, depending on where various competitions are. And I want a quicker way to be able to figure out if there's a bug that's come up that people are talking about, if there's some sort of problem, if there's some sort of like hot new machine learning trend that everyone's suddenly talking about, and to pass that information on to my teammates pretty quickly, as opposed to me doing it with my eyeballs, which is what I've been doing so far. So we're working on an NLP project to sort of speed that up. Good morning, everybody. Amit says, how long will the session be? They're usually about an hour, give or take. And that's just because that's how long it takes for me to make, like, a meaningful amount of progress while I am, make this a little bit bigger, meaningful amount of progress while I am also talking. I do code a little bit faster when I'm not talking about what I'm doing. So let's kick off. So my work is under notebooks, your work, and we have a couple of things here. So here's the big guy. It's not necessarily a guy. The big notebook that has all of the work that we've been doing, and we've gotten pretty far. So we've gotten to the point where we have clusters actually. So here is one example of a cluster. Excuse me, nose is itchy. One example of a cluster where someone's talking about, I was running a kernel about 2 hours, then ... Here someone says, the error shows that sometimes, not especially in ... And then, did you get a kernel restart when running, presumably? So it looks like this cluster is about bug reports and potentially the same bug report. It's a little hard to say without seeing the whole post. So this is a kernel, this is a cluster that we'd want to know about. And the problem that we're working on now, hello, Leonardo and Eric and Steven, I'm guessing, with a little bit of a different spelling. Welcome everybody. Sorry. I think I'm allergic to something somewhere. Who knows, man. An allergen, Dr. Wood, Rachel, you could just go see the doctor and they would tell you after they do the test they do with a bunch of pricks. I know. I just haven't done it. Anyway, so we got these kernels. Nope, clusters. I keep looking at the word kernel and then saying kernel. We have these clusters. And the thing that we've been working on for the last little bit is how do you take the information in a cluster and quickly convey it without just having everybody read the posts in a cluster, which if I have gone from reading all of the forum posts with my eyes to reading all of the forum posts in a given cluster with my eyes, like, it's a little bit more condensed maybe, because maybe I can skim after the first one, but it's still like the same total amount of reading. So it doesn't actually, it's like the map of Peru or Panama, where the best possible map is the country itself, right? But that's not helpful as an abstraction. So what is helpful as an abstraction is some way of getting the information and conveying it more succinctly. Hello from India, hello. So one of the things that we've been working on, and this did finally work, which is nice, is getting information on the frequency of various words on Kaggle. So we have this file that we spent all last week sort of waiting to run while we worked on other stuff. And the idea is that this file has the frequency of all of the words on the Kaggle forum, and we can use it as a resource going forward. And we have 4 columns, so one is just the index. we have the word, so the first word is the, and then to, and then and these are sorted by most to least frequent. And the raw frequency of the is that it's occurred, about 1 million times in the Kaggle corpus, which I think is... I'm trying to remember how big the total corpus is. I want to say it's like 5.6 million words? That can't be right. Every fifth word isn't the. Anyway, it's a pretty big corpus. It's all of the forum posts that are public and have not been deleted on Kaggle. And then we have the log frequency, and then this salience term is normalized so that you can compare frequency counts across corpora with different sizes. And the salience count is the log frequency of the current word divided by the log frequency of the most common word. So the log frequency of the most common word is the, and of course the is as frequent as itself, so it has a measure of 1. And then to and of is, etc. And as we go down, we can see that Kaggle has this salience feature of about 0.76. Public leaderboard, public submission is a salience of about 0.71. So this is a measure that we can use to compare things. And now that we have this, the idea is that we should hopefully be able to use this information to figure out which words in a cluster are most different from the words on the Kaggle forums in general, right? So the idea here is that we want a way to pick out, hey, these are the words that are most informative about the cluster, and have a way of very quickly allowing people to skim using that. So that's a general idea of what we're planning to do today, which I don't think I didn't put it in the title. I wasn't sure if I might actually do something a little bit different today, and I decided not to. So I will actually create a new data set from this so I can add it to other notebooks. And I'm going to call this Kaggle Forum Free Kaggle Forum Term Frequency Unstemmed. So we're not stemming here, we're not doing any lemmatization, we're just looking at the whole word. The only preprocessing that we're doing basically is that we're making it lowercase. So let's create that. And so from here, once we've created our data set, we'll be able to add it to our existing forum posts. So I go to the data set. I'm gonna add just like a little bit of detail. And I think I can add more detail here. Yeah. Word for word with frequency info, and the integer is raw frequency all Kaggle forums, and then the next one is log frequency, and then log frequency divided by log frequency of most common word, which is the. And let's save that, and that way when people come and look at this data set a little bit later on, they can understand what's going on in it. And I'm not going to do a whole bunch here, but I will add, is Kaggle a tag? It is not. I think most of our NLP stuff is under linguistics, so I think that's reasonable. Maybe computer science, because I think it is sort of computery. Do we have corpus as a tag? I don't think we do. Yeah, we don't. Okay, so I think that's enough, and then I'll make it public and you guys can check it out. And if you can see that it doesn't, if we look at the metadata, there's a lot of things I just sort of haven't specified. So I'm not, just not gonna mess with that. But I want to make it public. I've done this before. I think it's under sharing. That's right. Make it public. All right. So now people will be able to use this, and if you look on Kaggle, you should see this right away. All right. Robbie says Rachel becoming famous in India. Oh. That'd be nice. I've never actually been to India. I'd like to go at some point. Yeah, no, sorry, I'm just imagining, like, I don't know. I've never been. I think I'd probably want to go to Bangalore, because I know that's the big tech center, and then Hyderabad, because there's that palace that's super famous in acoustics. because my degree is in linguistics, and I did a lot of work with acoustics, and there's the one where you can like clap in the foyer and they can hear it in the master bedroom. Anyway, it's really cool. Really good architectural acoustic design, and it's from like 11 BC or something like that. It's really old. Yeah, that's what I'd like to do in India. That's my full itinerary. I'm sure there are other things I would do, but what was I doing? Right, I should probably edit this post and kick it off. So this post, we have all of our preprocessing, we have our clustering, we are using embeddings. I think we actually removed the part where we did keyword extraction because we had a weird bugs for not actually doing keyword extraction, which we could do and would probably make this run a little bit faster. So that might be a good choice. And you can see that we're downloading files. If you look at the meta Kaggle dataset, so let's actually do that really quickly. Most data sets have, I think it'll be quicker in here. Oh, have you guys tried the new search yet? Isn't it nice? Notebooks, comments. I think it actually has a space in it. Yeah, there we go. So most data sets that have multiple versions, you can see all of the versions, but you might notice that in the Kaggle, meta Kaggle dataset, there's only one version, even though it's updated daily. And the reason for that is that we want people to be able to like remove their data from Kaggle, and if we have a data set that still is hanging around that has their data in it, then it's not removed, is it? So we remove all the previous versions, and every time you relaunch a, not all. Every time you relaunch your kernel, if the data set itself has been updated, you'll have to reload it in all the way. So that's why that takes a while. All right. So we've done quite a bit of work, and we'll get down here to what we did last week. Oh, we actually did way more than I remember doing. Yeah, nice job, Rachel, from last week. So we are looking at a specific cluster here. And what we're doing is the same calculations that we did when we calculated the frequency, except we are doing it for a specific cluster. And the idea here is we want to see, so we have our normalized frequency counts, right? So they're normalized to the size of the corpus, so we can compare against corpora of different sizes. Here we're using a single cluster as a corpus. And what we want to know is what words have moved the most in frequency between the original cluster, between the total Kaggle forums and this particular cluster, and particularly what's gone up in frequency. So if people on Kaggle aren't usually talking about some sharing, and they're talking about sharing a lot in this particular cluster, probably there's something going on there that the Kaggle team should know about and look into. Maybe there's some sort of bug, maybe there's some sort of, I don't know, I'm trying to think what other things could be sharing. Someone shared something really cool, and everyone's talking about like, oh, thank you for sharing, and we probably want to take a look. We like cool things. So that's the sort of general idea. And this is the normalized frequency for the specific cluster. And you can see some of these are 0, have a normalized frequency of 0. So U here is the most common word, so its normalized frequency is 1. The here is much less common because, I don't know, just the way the cluster worked out. Generally, you'll tend to get convergence towards the most common word in a corpus for a specific language if the corpus is on, more or less the same topic. Well, most common words are pretty stable, and as the size of the corpus increases, you tend to get more shift towards that. So people are talking about you much more than they do in other contexts. Could, thank is more common, maybe, I don't know what it is in the rest of the corpus. And then we have a bunch of these that have a log frequency, a saliency score of 0, which I believe means that they've only showed up once. So we could do, okay, so we could do a little bit of normalizing. Let's see what that changes. So what I've done here is I've added 1 to the frequency of the word, and that keeps us from having values of 0 here. So it's smoothing, basically. I'm just doing a little bit of smoothing. Actually, what I can do that might make this a little bit easier, because the thing is the frequency counts are so low that that small amount of smoothing is like kind of a lot. One is actually probably too many, so we'd probably want to add like 0.01. Smooth, let's run that. And now we should have, right, noted. Okay, yeah. So what we've done is we've added the saliency measure to this dictionary cluster dict, but we don't have any place where we've put the cluster dict smooth. We don't have any place where we put the smoothed information. Smooth word. No, word is the thing that I'm looking for. And then saliency measure smooth. There we go. Okay. Oop, cluster dict. Yep, that's a typo. Yeah. And then smoothed. All right, so here I haven't added one. I've added a much smaller number, and that's just because it's unlikely that you'll see rare things, right? So you are, depending on the size of your corpus, almost certain to have something that's out of vocabulary. And if you say that you've seen it 0 times, then if you have a bunch of zeros in your, your various frequency measures, it can make the math wonky. That's why you do that. Vicus says, are there any standard libraries or methods for analyzing text data for NLP pipeline? It depends. The method is going to depend on your specific question. Libraries, I like NLTK, which I think we've used here, the Natural Language Toolkit. Spacey is quite good. That's more production focused. You don't have as much flexibility, but it tends to run a little bit faster and be better optimized. GenSim is pretty commonly used for sort of topic-y stuff. Yeah, NLP is a big field. There's no I can't be like, here's the thing that everyone does for everything, because it's just so diverse. I wish I could be like, here's NLP in a sentence, but unfortunately, yeah. Alan says, a bit surprised that does not have a normalized frequency of 1, but U has. So that's, I think, a function of the size of the cluster. So it's let's actually get the text, and I think we should see that it's probably like 2 posts, and it's just not that big. Actually, we already have that, so let's just look at the text and see what that looks like. Thank you for sharing. I tried your code of ROC, so ROC, but I got an error, which is 0 division error, division by 0. Could you help me how to fix this? Thanks in advance. Hi, could you please help with the code for relaxed data function? Could you please share me the answer for module 1, PW items by region? Thank you for the response above, but it's a screenshot of my computer screen. I would be glad if you could assist me with this. So basically, this is a cluster of people asking for help. And the /n's are divisions between, yeah, I don't know where we're getting them. But I was wondering if we were putting them in during our pre-processing, and I don't think we are. But there are divisions between the posts. So you can see this is 3 posts, maybe 4 posts actually, and people are just asking for help, and they're saying you a lot in their asking for help. If we had a bigger sample of people asking for help, I imagine the would be the most common word. Yeah. Ryan said you could add 1 within the numerator and denominator of the logs, then you wouldn't end up with above 1 overall. Oh, that's a good point. Okay, so I think that's a number. Let's try that. Yeah. Pro strats from Ryan, thank you. Little T. Okay. So now we have a smooth dictionary, and we can try them both and see which ends up more reasonable. My intuition is that the unsmooth dictionary is going to be a little bit weird. The errors are going to be a little bit weird. So let's actually do the rest of the thing. So we need to add our data set. My data set's sorted by updated. There we go. So there's that data set we just created with the output from the other kernel. So I can do that. I believe I can update this. So if I reran the kernel and I wanted to update it, there we go. I could update it under new version, and then say what's going on. And then if I reran this kernel and I got new output, I think it would automatically update it. 98% sure that's what would happen, but also potentially, yeah, also potentially something to look into. So, all right. Enrique says, not sure why you're not removing stop words. So, yeah, the main reason that we're not removing stop words is that would make the normalization by the most common word very funky. Because stop words tend to be the most frequent words. So if we had like a nice, logarithmic curve, and we just remove like the first part of it and then some of the chunks after it, we'd end up with sort of like a weird, we'd end up with a little bit of a weird distribution. Oh, sun. Ugh. Nah? No. What if I'm very far forward? Nope. Okay, well I need a little bit, but not enough that it's casting a shadow. Okay, there we are. Chroma keying is very light sensitive. All right. Yeah, so I mean that's also something you could try is try removing the stop words and see how it changes your results. But it's doing that thing where the code's there, it just looks like it's not. So, do we have to rerun everything? I think we do. Well, let's do that. All right, so then we will have added the yeah. Okay, so the thing that we've done so far is that we've gotten the frequency information for the specific cluster, and now we're interested in the frequency information for the for the words that occur both in the clusters and also in the whole corpus. So get the normalized frequency for each word in the dist. Dictionaries have multiple columns. Is that going to be the best way to do this? I'm going to try that as well. No, that's much worse. That's much worse. Mistakes. Sorry, I was trying to fix the lighting. Let's try this. Okay, better. Okay, we're going to want to loop through it at some point. No. Okay, why would we use a dictionary here? I don't think we... I think this is small enough that a data frame would actually be fine. So maybe I'll do that, and I might create two arrays and then concatenate them as columns in a data frame. Because I think column concatenation is not that slow in pandas. It's a little bit slower in R, but I think pandas has... I don't know if pandas dealt with them, memory management problems. If you're not familiar with R, it is the language that pandas is based on. It is an incomplete port of the R language, which makes it a little bit frustrating if you're used to R. Oop, did I get an error? Float division by 0. Interesting. Will that work? I don't think that'll work. Well, let's find out. Someone has forgotten the order of operations. It's me. I forgot the order of operations. That gonna work? I don't think that'll work. Yeah, that won't work. All right. Float division by 0. All right. So you are that one. It shouldn't be divided by 0, though. Ah, dang it. And I'm having problems with the chroma key again. What if I rotate this? Will that help? No, that don't help. What if I do it that way? Nope, that's worse too. Ah, okay. I need to change my lighting setup. This is untenable. Nope. Nope. I'm just turning off the video capture device. This is unfortunate. Yeah. I can't handle it. It's too frustrating. I also like R. So I think that's what I'm gonna do. Why? Is it specifically the smooth one where I'm getting the problem, or is it the other one? No. Okay, so the most common word, let's get rid of this, make this bigger. So the most common word has a frequency of 0? That can't be. That's not. No. Surely not. Yeah, no, it's 1. It'll always be 1. Reviewer 2 says, haven't they ported data table to R? They have. I believe that is a H2OAI has done that. Also, this will always be 1, so we don't need to fetch it. We can just divide by 1. I don't know why that didn't occur to me earlier. So the reason it will always be 1 is because the No. It won't be 1. No. Oh, no, I'm absolutely wrong. Sorry, I was thinking it was 1 because the normalized saliency is going to be 1, but the pre-normalized saliency can't be 1. All right. Let's look at the first most common word. All right. Just is the most common word. Oh, right. These clusters aren't deterministic. So let's check out the text. I just received SQL Summer Camp certification, which is apparently a cluster all on its own. I think there were definitely more posts around that. And that went out yesterday. And if you think you should have gotten that and didn't, I guess email me. Robbie says, I use data table in Python and also in DAR. I like data table if I am not paranoid about data loss. If I'm paranoid about data loss, I don't use it. Neri's like, it's because you're trying to take the log of 1. All right. I think we'll just use the saliency measure to... Okay, so I think, remember when I was like, you don't want to use 0 because your math will get weird? This is why. This is why you don't use... just. Okay, yep, that looks good. All right. And so even though I've added a very small amount because I've added it to both, we don't end up dividing by 1. Thank you, Ryan and Neri for the tips. It would have taken me probably a good... I have no idea how long it would have taken me to figure that out. I would have gotten to it eventually, but thank you. A little sip of tea. Okay, let's... So all of these words are going to get equal importance. Let's try cluster 1. All right, there we go. That's going to be a little bit better. So we have this cluster, and if we take a look at it, we can see it's fairly long. Someone talking about even treating xtext missing columns value separately, low cardinality for xtest, assist, or know about a similar problem. So this looks like somebody asking questions about the submission file for a particular competition, I'm guessing. And we would want to see xtest to have a very high value here, or it'll move a lot, because this probably occurs in our full Kaggle corpus. So We want, all right, so we have words. All right, let's take a look at words. So these should be the unique, oh, that's a markdown cell. Why won't my code run? It's a good cue, Rachel. Why won't your code run? We actually might want to loop through the fdist most common. So this is the frequency distribution that we have. And the most common, if you just ask for all of the most common, you'll get, if I ask for the most common 5, I'll get the top 5 words. If I don't say how many I want, I'll get all of them in my lexicon. Okay, so this is the raw frequencies. We also have the normalized frequencies in our cluster dict object that we've made. So we want a way to get for word in, I'm just going to print for now, print cluster dict. Did I actually read in my, I don't think I actually read it in. I don't think I read it in the frequency table. Read underscore CSV. And then it's an input, and then it's called unstemmed, and then we want the CSV. End of line while scanning string. Oh. If we use correct syntax, probably it would work better. All right. Error tokenizing data expected 4 fields in line 2532 saw 5. Okay, so there's probably somewhere a comma / tab that is giving us problems. Because you can see, I'm pretty sure I tried to remove punctuation. I think my regex might have been a little bit off. So I think we are running into trouble because there is a comma. Pandas, skip row, read CSV. I only want, I want to skip that particular row. Let's see. Skip initial space, skip rows, none. All right. What's the syntax for that? Skip rows. Line numbers to skip, 0 index. So let's do. Rachel, you could go back and fix the input file. I could, but I'd have to rerun the code, and it takes a minute. So I'm not going to do that. All right, skip rows, and then it's a list. 2532? Maybe it's looking for 2531 because it's 0 indexed. 2652. I'm just gonna do this by hand. Oh, that's right. I think I have to subtract 1 from each of them as well because it is because it's 0 index, not 1 index like humans use. No kid counts from 0. It's ridiculous. All right, and this one is 4017. 4430. We may be here a while. 4856. How big is this? 4931. $52.52. All right, we're getting there. $53.89. $55.54. Surely there can't be that many left. 5667. If somebody knows a faster way to do this, please let me know in the chat. 6677. Oh, and it looks like thanks 1342 on Twitch also helped with the log problem. 7001. 7505. At least they're not right next to each other, right? We're getting a good couple hundred in between. 7532. And we can't just say use tabs because we used commas. 7656. Oh, right, 55. 7656. Oh, are they just right next to each other? Yeah. 76. All right. Okay. Nope. This has been long enough. There's got to be a better way. That still hasn't been fixed. I have filed a bug for that, so hopefully that'll happen soon. Data sets. Enrique says so many. Yeah. I'm done with this game. Skip initial case, skip rows, skip footer, end rows, skip blank lines, skip blank lines. Skip rows, warn bad lines. Equals false. One mad lines equals true. And in Python you don't want any spaces, I believe is the style guide. Let's try that. Yeah, I'm glad sure glad we didn't try to do this by hand, huh? All right, there's a fair number of them. So we might want to go through and fix our initial data set. Sort by updated, which should be our most recent one on top. It is. Does this link back to the data set, the kernel we used to create this? Data source, yes. Oh, no, it doesn't. Okay. So the little link there, information just tells us that it is a data source. And I think the simplest answer for this is actually going to be notebooks, my work, frequency and saliency. Instead of using comma delimited, then using tab delimited. Oh, airline badge equals false. And then bad lines will be dropped. Okay, helpful. What are we doing today? We're still working on our little, our forum frequency project. So actually, I don't think I even want a warning. Goodbye. Ignore. All right. Okay. And it just shows us all of the ones that it skipped. And let's just, for our own happiness, hide the output. So when we look at the data set, when we look at the kernel, once we've committed it, we won't see that. All right. So now we should be able to look at the head of the frequency table. Nope. There we go. Sometimes I remember the thing. All right. So here we have the word, the raw frequency, the log frequency, and then the salience, which is what we're looking for. So I'm just going to double check my syntax. So if we have frequency table dot word equals the, can we then do like frequency table and then dot say, no, I've got insert on, frequency is nothing, dot saliency. Will this get us 1? It will. Fantastic. So we can use this to get the information that we are looking for in our loop. Word, and then instead of using the, we can use word. And I'm just gonna print all this real quick, and then we can figure about putting it in a trace back, most recent word. Let's take the key error, the 14. Oh, I see. So this thing where we're doing the two variables from one in a two, I forget what that's called. It's some sort of Python nonsense. It's not nonsense. It's very helpful. If we don't use that, then the whole tuple is assigned to the thing. And if we do use that, then the first part of the tuple is assigned to word, and the second part of the tuple is assigned to frequency. And I'm just not going to use frequency. All right. So here we have the frequency in the dictionary for the cluster, and then the frequency in the whole data set. All right, I'm going to quickly see if the video is better. Nope. It's worse. Okay. I'm going to do some rekeying later on. I have an east-facing window now, which means that I got lots of exciting variation in the type of natural light that comes through. Fantastic. I love it. All right, little sip of water. All right, so the thing that we want to do is actually, we want to subtract these. We want, Thanks says you have a typo in frequency here. It doesn't matter. I'll reduce it to freq, but I'm not going to use it. I'm just using that so I don't have to, so I don't get a tuple back. I actually do get a word back. So I want to weight things highly if they move up. So if they have a low frequency overall and a high frequency in the cluster, I want a big number. If they have a low frequency in the cluster and a high frequency overall, I want a small number. So I think I want to subtract this direction. Yeah. Nice. Okay, so positive numbers mean that if it's moved up, negative numbers mean that it's moved down, right? Corvus says it's a good thing, right? The natural lighting. It is and it isn't. It's nice because it's a light source. The downside is that it is very variable, and that means that like the color of the green screen behind me keeps changing. Which means that because the chroma keying is looking for a specific range of RGB values, it doesn't see it anymore and it starts to ignore it. So things are no longer being removed by chroma keying. So I did not think that knowing about green screens would ever be part of my job, but here we are. All right, and let's quickly print out the cluster dictionary just for a little bit of a sanity check. So xtest should have a very positive number, and should have a negative number, and positive and negative. Fantastic. This is exactly what we're looking for. So this is the okay, so what I'm thinking here is how am I going to attach the specific word to this information? The first idea I had is, I'll put it in a dictionary. The problem is that I'm going to want to sort this, and dictionaries are not by default sorted, and sorting dictionaries is awful time complexity because of the way that they are. So I think I want to put this in I think I want to put it in DataFrame. PD pandas add row to data frame in loop. This might be a Stack Overflow where people are just like, don't do it. Do not form a new data frame with each row. Instead, collect all data in a list of dicts. Then call dataframe.pd dataframe data once at the end outside the loop. Okay, so do put it in a dictionary. All right, and then create a data frame from the dictionary. Each call to append requires allocating space for a new data frame with one extra row. Oh, okay. So the memory management problems are exactly the same as they are in R. You never want to use rbind in a loop in R. Avoid loops entirely because of the way the language is. The time complexity is worse than it would be in other languages. But definitely don't allocate memory every time you go through a loop. That ain't no good. 8. Kova says, is the first printed number the index and then the frequency? Yes. Oh, wait. Hold up. I think I got this. I don't think we actually have to look anything up. Oh, yeah. that would give us... Okay, so we have the X test. Okay. So all we want to do is take these two and put them in... Yes, so so we're combining across a dictionary and a data frame, and this is the index from the data frame that has the information on all of the Kaggle forum post word frequency stuff. Yeah, so we can actually ignore this index. It's not going to be helpful because we're only interested in things within the cluster. So... maybe actually an array would be faster than a dictionary. Right? All right. At least for the Python lists can be used instead. All right. All right. Never mind. I guess we're making a list. Use the length method to return the length of an array. Looping, blah, 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 blah. Okay, excellent. And then append. So let's do words equals, and I think we can just create an empty list, and then we can do, what should we call this? Freak saliency? Surprisal, maybe? I think Surprisal has a different... I think Surprisal has a specific definition in information theory that I'm not following here, but you know what? We'll just work with it. All right. So words.append word, and then we're gonna do Oh, interesting. Oh, I've already mistyped it. I was like, why isn't my append? Why isn't my very cool code words? Yes. Surprisal? Okay, I just want the value out. Yeah, I just want the value out. Interestingly, only a couple of these things actually have a positive value, so we might actually just be able to use just the things that have a positive value as like a super fast way of figuring out what we want. Okay, so what's the data type that we're getting back here? I think it's because we are subsetting a... what if we ask for just the second thing? That don't work. All right. I just want the value. I don't want all of the data frame nonsense. Python get just float from data frame. That's what I want. Trying to exact as well. Yeah, I don't want all that nonsense. How do I do it? Output is a series with one value, so there are more possible predictions. Okay. So I could just do just item, apparently should work. And actually, let's split this up because this line is getting too long. So, Surprisal measure. All right, and then we'll do Surprisal measure dot item. See if this works. Item has been deprecated and will be removed in a future version. All right, let's not use that, huh? All right, so we can use value 0 maybe. And then this should, yeah, there we go. Excellent. So now we should be able to append these into a data frame, hopefully. Nope. Pandas data frame from list. That's what I want. No, I don't want any of this. All right, let's do this because I think this is what we're looking for. Doop-a-doo-doo, doop-a-doo-doo. Okay, so we want to do a data frame that is a list of words and Surprisal, and then we want words, and then we want Surprisal. Where Surprisal is just a change in saliency. I don't know why I said just there. That's several layers deep. And then nice. That looks great. And then let's actually call this cluster Surprisal measures, because I'll be doing this quite a few times with each, because this is going to happen once per cluster. I think it might be worthwhile to spend some time working through this and making sure it's fairly well optimized. Although the number one place where we would be in trouble is this this for loop, and I think that should be actually pretty okay, hopefully. Because appending to a list is not that bad in terms of time, whereas appending to a data frame is generally. So then we look at the cluster Surprisal measures. Bubbity boop, looks good. Dot Surprisal is greater than 1. Oh no, sorry, greater than 0. So we just want positive ones, and then we want the words. All right, so the words that we could use, the words that have a higher frequency than expected given the overall frequency in this particular cluster are xtest separately, cardinality, redefined, and oxtrain. Which I think is pretty good. We might want to put like a different bound other than 0, but for this I feel like this is actually like a fairly good quick summarization of the information that's in this cluster, so I'm okay for that so far. And let's call this surprising words. And then we should be able to look at surprising. And I'm just running this whole cell every time just to make sure that it's all working good. All right, so this looks good. So I think we're actually ready to put this puppy into a function. Get surprising words. Because we don't care about what people aren't talking about, right? We only care about the things that they are talking about. Is that the syntax for functions in Python? Let me double check. Nope, not the math one. Nope. Oh, I see. I see why I'm getting math. There we go. Def. That is absolutely not the correct. Yeah. All right, there we go. I'm thinking R. So def, get surprise words, and then the information that we need, and then that. So what are we looking for here? We are looking for the cluster dictionary. We're using that. And then the frequency table. All right. So if we define this, and then we run it. Oh, we'll get nothing because we're returning nothing. Surprising words. There we go. All right, so that should work. And then if we do so, and those are the things. That looks better. We run that, redefine it, run that. We should get the same output out, and we do. Fantastic. Okay. So then we just need other functions to create what I do. What happened? Did I just move it? I just moved it. Okay. Goody. So then we need other functions to create the cluster dictionary, and I think that's already fairly well modularized, so we can call this cluster. Nope. Def get cluster saliency dict, and it requires cluster. Okay, so the only information that you would need here is specifically the cluster number, because it doesn't rely on the other file that we loaded in. So cluster number here instead of 1, def cluster number. All right, fantastic. And I think actually it'll be a little bit easier for us if we have these two rely on each other. So we're going to create this cluster dict that we're using in here somewhere. Word append word cluster dict. Yeah. Cluster underscore dict. We're going to use this function. Get cluster saliency dict. And we're going to use the cluster number that we passed in. So, boop. If we do get surprising words, 1 frequency table. None type object, not subscriptable. Get surprising words, 1 frequency table. All right, surprise to measure, cluster dict word. Frequency table, that word. All right. All right, let's double check. This guy gets cluster saliency dict. Over cluster 1. Friends, I did not return anything. All right, once more from the top. And now this should return a dictionary. Hey ho, there's a dictionary, and we should be able to get rid of this, and this should give us our surprising words. Took a second. And if we run it on other clusters, key error the. All right. Okay, so the problem here is that we are relying on this frequency distribution most common, which we calculated in the cluster dictionary here. Okay. All right. And then fdist. I think we can do it like so. think this will work. Let's see. Boop, boop, boop. Yeah, fantastic. So we can see that all of the surprising words, because all of these had a value of 1, if you'll remember, because they are all the most common word, and they are not the most common word on the Kaggle forums. So just received SQL Summer Camp certification. That should work. And let's see. Will there be a URL where the Kobe says your surprisings are different on every line? Yeah. I mean, I'm using tab complete, so it doesn't matter a whole bunch as long as I'm consistent, but and then the URL, so the data set is actually already, it's public. It's forum post embeddings clustering, just not the work that we've done today specifically. That's not available. And if we do 3, oh, error, okay. Index 0 is out of bounds for access with size 0. Surprisal.append, Surprisal measure values 1. Out of bounds for access 0 with size 0. Okay, so it's Surprisal is happening here. Okay, so what's happening here is that it is showing up access 0 with size 0. So we're getting nothing out of here. Interesting. I think it could be that that particular cluster is empty. No, okay, definitely not that, because we're also getting that with cluster 1, which is the big cluster. Because if we look at cluster 0, you can see that there's plenty of stuff in here. Interesting. All right, so that works. And actually, let's do cluster 1 instead, because I think that has the best output. And then let's show that cluster 0 doesn't work. And actually, I think once we've done that, we'll be honestly more or less done with this stage of the project, because we'll have, so we've gotten a way to get the clusters from the forums, and the thing that we're adding now is a way to like summarize the information in the clusters. And it's not quite visualization, which I talked about for a while, but honestly, I think this is more informative. Yeah, we might be more or less done with at least the first stage of this project. If you watch the very first video, where I think it's called Scoping an NLP Project, you'll see that I have grand plans for a number of reasons, for a number of possible things, and that we've just sort of been working on the first stage of this project. So, to do, why do I get this error? Yeah, so it's working fine if the thing is showing up in both the frequency table and the cluster dictionary. Hold up. I've got an idea. I think it might be this. No? Okay, that works. And then if we have, let's say 10 minus that. No, it works. It just gives us a nothing. And then if we do x dot values, what do we get? Figured it out. Okay. So what we can do is we can do a little, oh, sorry, I should have clapped in the mic. Enrique says, how many clusters? I don't actually know for this particular one. The number changes. I've based the initial number of clusters on the square root of the number of posts on the day that we're looking at. but I have no strong reason a priori why I think that that's necessarily the actual number of clusters, and there are usually some empty clusters. So what are we looking for? Python check if values exists in series. Series empty. All right, so where is this error happening specifically? Surprisal.append. Surprisal.append. If, what was it? Pan does, sorry, PD dot, oh, I can just say the series. Dot empty plus. Surprisal. Actually, up here where we do our smoothing, I'm going to make these numbers smaller. Append, and then we're going to do cluster dict word, and then we're going to subtract by the smoothing value. .001, right? Was it 3 zeros or 2 zeros? 3 zeros, okay. So let's run you real quick. And this should fix our problem. And this is going to take a while because it is far and away the biggest cluster. I should probably have done it with one of the other clusters. That was smaller. All right. This could be optimized. So you can see that the words that are specifically representative of this cluster are to, Kaggle, GPU, DOI, reckless, add, underscore, infraction, Unulan. I'm guessing this is a person. Units, early birds, and then witch hunt. Which I think tells me that this is a very diverse particular cluster. Get rid of that. We solved the error. Good for us. Gotta think about edge cases. I guess some sort of software engineer or something. No, it's good to think about edge cases. And I'll do the same one for this one. And this is just a little one. This is just a little validation for me just to show that it actually works pretty well. All right. So I'm going to wrap it up for the day there. I'm going to commit this so you guys can check it out. Again, you can find it under forum posts embedding clustering Tatman. And I think if you just search for forum posts embedding. All right. Oh, forum post embedding. There we go. It is pretty. Our search is pretty sensitive to typos, which embeddings. There we go. Forum posts embeddings will get you to the notebooks, and you can see there's a bunch of other people who have been playing around with it and leaving comments. So, all right. Thank you for joining, everybody. Kova says, I love the live coding series. You inadvertently teach me bug hunting and crushing them. like to think about like putting them in a cup and taking them outside and removing them from my personal life forever, hopefully. But good. I'm really, really glad you guys find this helpful. Glad we got to the bottom of that bug. It was a nice satisfying finish. And we might actually spend next week working on making this like, maybe working on speeding it up a little bit, because it's a little slow. And I think that that's probably something to do with my loops and my clustering and the way that I'm doing it. And I can probably use more efficient data structures. And also maybe just making it like human readable, so that it's a nice report that I can run once a day and send to my engineering colleagues and have them look at it and see if it's relevant to them. All right. Thank you so much, guys. I hope this was fun and enjoyable, and I will see you on Wednesday. We're going to continue with the weight agnostic neural networks paper, which, y'all, this may be one of my favorite papers we've ever read in the reading group. I am just enjoying it so far, enjoying it so much. I'm actually reaching out to the authors and being like, will you do a coffee chat, please? I want to chat. It's such a good paper. All right, so enjoy your weekends if you're close to it or already in it, and I will see you guys on Wednesday. I'll talk to y'all then. Oh, or I guess I'll see you on Kaggle before then, so I'll see you all on Kaggle first. All right, bye!